This course on illumination engineering and electric utility systems services. Today we are looking at the lesson 12 titled Illumination Systems 2. That means we had a lecture on illumination systems 1 in lesson 11, wherein we covered for various applications what comprises a illumination system. In fact, it is not enough if we have a source of light. Source of light essentially tries to create the conditions necessary for us to work and be able to view the things and assimilate the information. But having various types of sources, effective usage calls for a complete lighting system or a illumination system, which consists of a source, a gear or a hardware which gives the physical support, which we call luminaire, which was extensively covered depending on the type of application and trying to be integrated with the overall requirements of the environment, and then the ability to control the light flux is what we need. So, that means in doing this there are certain accessories necessary to be able to use the illumination system in an effective manner, and in order to do that we look at in this lecture the accessories necessary for a complete lighting system. So, the first objective therefore would be to understand the accessories employed in illuminating systems, or one should be able to list the various accessories necessary to be employed in an illumination system. Then what is a ballast, and we find that most of these applications would have a common accessory as a ballast. So, the second objective has been therefore rightfully termed a ballast. Third objective is there could be variety of ballasts, so one should be able to list various types of ballasts. Now, depending on the nature of the source, nature of the application, one may have to use varieties of ballast, because ballast by itself means the one which boosts or creates the appropriate voltage current conditions, remembering that most of these artificial sources are powered by the electrical energy. That is to be borne in mind. Now, it may not be enough if you have a ballast, you have a control gear. In fact, luminaire itself partially acts as a controller, trying to direct the light flux in the area where it is required, and at times there is a need to have some kind of a starting devices, because we saw the various sources of light have been employing the principles of incandescence, then electroluminescence and fluorescence. Now, all these, if you accept barring the incandescent, they are some kind of a discharge lamps. There is a discharge in a gas or a metal vapor, which means we find that the discharge has to be initiated, and this initiation, as observed already and as may be seen, calls for a higher voltage than the operating voltage. This is what makes it necessary to have a starting device. So, as we observed in the last lecture, the fundamental thing is a lamp is a radiation source in a illumination system, and the radiation source, as I already told, it could be a lamp, incandescent lamp employing the principle of incandescence, which is essentially a thermoluminescent phenomena where the filament being maintained at a temperature gives out the radiation, and this temperature rise is attained by the passage of current flowing through the filament. 2 is a luminaire. Luminaire, in fact, we said primarily supports the lamp. It has the lamp holders. Secondarily, it directs the light along the direction in which it is required. Say you have, and we have seen that these luminaires come in variety of shapes and sizes. Most commonly, the luminaires are suspended from the ceiling. They could be mounted, recessed in the ceiling itself, and there are certain diffusing luminaires which are essentially in the form of closed envelopes like ellipsoidal or spherical, which are used on certain ornamental lighting in gardens, which are also called as post-top lanterns. The control gear, what does it do? It helps in controlling the requisite amount of flux on the work plane. Now, in the early days, the only control was by suitably mounting the lamp and having luminaire with appropriate reflectors. The early reflector was some kind of a reflecting coating placed in the interior of the luminaire, which directs the light onto the or in the direction of the task on hand. But later on, it has improved with the help of having mirrored reflectors, prism reflectors, so on and so forth. This apart, there are certain applications where you may need varying levels of light flux with at different instants of time. Now, these are all possible quite conveniently with the help of modern electronic controls. That is what would form one form of an accessory in controlling. Now, let us say we have about 5 to 6 lamps placed in one luminaire, each giving out say 1000 lumens. But all the time we may not need this 6 into 1000, 6000 lumens on the task. One may need much lower level at times. Maximum level may be required when there is a critical task going on. The simplest control one can think of is a switching mechanism where you have few of the lamps based on the required illumination level are switched on, or group controlled switches. This apart, there could be a mechanism of controlling the input voltage whereby the light flux can be altered. That is, you have what are called as voltage regulators placed in the input in the switch, similar to our fan regulators. What do we have? We have a fan regulator is essentially in the crudest form is a set of rheostats with a potentiometric knob, so that by choice of the appropriate resistance, amount of voltage applied to the fan is reduced or increased, and thereby the speed gets controlled. In a similar manner, you could have a way of regulating the voltage, and these in fact are being using alternating current invariably employ things based on the auto transformer action, and in early days were essentially being used for dimming or increasing the light control, and hence commercially were being known as dimmerstats too. Now, this apart, right in the beginning we said one of the objectives of this lesson has been to understand or say what is a ballast. In fact, in talking of the physical processes involving electroluminescence and fluorescence, we said both of them involve some kind of a electrical discharge which gives rise to illumination, and this discharge necessitates that there is a particular voltage required, which is most of the times more than the normal operating voltage. To achieve this, in fact, a ballast is used. This apart, once the arc is struck, one needs to maintain the current. In fact, arc voltage current characteristics are such that it tends to maintain a reasonably low voltage drop across that with a constant current level. Now, in order to have this, and in order to avoid current building up ad infinitum, there is a need to have current limiting, also current limiting device in series, which we can say is an impedance. Now, the ballast which we are thinking of has two roles. One, to give the necessary boost in the voltage so that the discharge takes place. Two, to limit the current when the arc is struck. The two have to be achieved, and in fact, it is believed that both can be easily got in one shot, especially on AC circuits having what we normally know as choke, which is nothing but a coil, and or it is an inductance having predominantly inductance property. The idea is inductance does give the required current limiting ability, number one, and one of our objectives has always been to optimally utilize the energy. That means there should be no power loss in any of these accessories which we are using. So, inductance becomes a very good candidate in that sense that it acts as a current limiter without undue loss of power. However, the problem is of course that it being predominantly inductive has a low power factor. We try to choose or have circuits accessories in such that power factor is maintained as high as possible. Recall that although power loss is not there, by virtue of the presence of inductor, there is a reactive power consumption by the circuit, which amounts to having a increased line current from the supply, and that is what means you are forced to have higher conductor cross section at the input. In order to again optimize there, one needs to see what can be done to improve this power factor, and at the same time, being in energy storage elements, these tend to have their own natural frequencies which tend to generate harmonics. So, we need to design these coils, ballasts in such a way that they generate minimum harmonics, and it should not generate frequencies in the radio or TV frequencies, so that the interference takes place. And this in fact is these days the generated interference signals due to such energy storage elements in the networks is what we call electromagnetic interference, which was in early days called radio interference and TV interference. So, we need to have a ballast such that it operates near at a good power factor, does not consume energy, at the same time see that it does not create electromagnetic interference. Normally, we find that these are reactors or inductor coils. They are wound on a magnetic core, in fact colloquially known as choke, and they are kept in series with the lamp, and typically they have a lagging power factor. In fact, this picture here shows the phasor diagram where V choke and I choke are in an ideal situation in quadrature, but in practice it is very difficult to have a ideal inductance. We do find that there is certain resistance or loss associated with any coil wound with the help of a conductor, and is seen to have power factors of the order of 0.5. Now, incidentally, introduction of a capacitor improves the power factor. It also acts as a device to minimize harmonics and suppress the interference. In fact, here is the complete schematic of a discharge lamp with all its accessories and the associated phasor diagram where one could see. In fact, this inductor or the ballast in fact is a coil wound on a magnetic core. Vs, Is indicate the supply. The way it is connected is in series, therefore the I lamp is same as the I supply, or IL is equal to Is. Now, S is the starting device. As already discussed in talking about the discharge lamps as well as fluorescent lamps, we did mention that to create the discharge one needs to create over voltage across the two electrodes. The vertical column, rectangular column, denotes the lamp. The two ends are the two filaments which are the two electrodes across which the arc is stuck. So, this shows how one has normally a 0.5 lag power factor. On the other hand, if you place a capacitor in parallel, we find that although the lamp current still is lagging in nature, we improve the supply current, as can be seen compared to the previous diagram. The power factor angle between the phase angle between the voltage phasor of the supply voltage phasor and the current phasor has considerably reduced, and this is one way. The other ways to achieve this are what we call lead lag circuits. Now, we have seen in this, when you have one lamp supported by one ballast, gives rise to a lagging circuit. Supposing in a particular luminaire, because it is a common practice in offices to have more than one lamp in one luminaire, two lamps is a very common thing, and larger work areas you do find trying to go closer to a sheet of light by having more than 2 or 4. In such a situation, one could have a common supply point for a set of 2 fluorescent lamps or discharge lamps, with one being fed a lagging current, other being fed by a leading current. That means, in a series with one of the chokes, you have a capacitor to improve, and as a result you have overall power factor improved. So, this is the thing, you have a ballast which is predominantly inductive. Now, since you have an inductive ballast, what happens? Initially the current flows through the inductor through one end of the electrode of the discharge tube and through the starting device S, which is closed, and the other electrode back to the supply. Now, if this circuit is broken at some point, the starting device opens. In fact, one of the most common starting devices which we have been using is the bimetallic starter, which on passage of current, because of differential expansion, opens out, thereby there is an interruption in what we call a RL circuit and leads to a transient. The current interruption in a RL circuit, as already known, gives rise to a voltage build up or a voltage transient, which creates the discharge. That is what is done. But there are certain areas of application where one cannot have such a interruption. That means one cannot have a starter. So one looks for what are called starterless circuits. That means there is a need to have some amount of pre-ionization in the discharge tube, and this is obtained by having what we call the preheated filament electrodes, and these get from the same choke. You could have a secondary of a smaller rating which gets the required voltage to heat the filament electrodes. This can be seen, in fact what we see here is you have a choke or a inductance coil with a series capacitor in a resonant mode to create the required over voltage. Remember, that is a resonant circuit. In fact, though maximizes the power drawn series this thing and creates a voltage build up across the energy storage elements. As you can see, there is a single transformer which is feeding both, and there is a reduced voltage is taken to heat the filament electrode. Now this becomes necessary in certain areas where you cannot allow any interruption in the circuit, that is any opening may lead to a spark which could lead to some explosion, especially in the explosive environments this is preferred. Now in fact this shows yet another scheme of having this, and in fact the envelope of such a glass tube is to be taken care so that even when you are operating in cold environments, it does not transmit the low temperature ambient temperatures to the filaments and thereby reduce the preheated, because that calls for higher this thing. Now this was fine as long as we were talking with AC. What happens in DC? DC, there is no option, because recall that onto a DC excitation the inductance behaves like a it does not really operate, it behaves like a short, and therefore it does not offer any impedance and does not limit the current, yet you need to. So the only way out is to use resistors, but we all know the usage of resistors leads to power loss. In fact, this is where the modern day electronic ballasts employ what are called as a power electronic circuits, whereby DC input is converted to high frequency AC around say 20 kilohertz, and then it runs a normal ballast. Thereby the idea is, importance is, you do not waste a lot of power in the resistors. So that the other problem is, the moment you use resistors, building up of the voltage overvolting required for the discharge lamp becomes difficult. And how do we have to resort to having those preheated filaments only? Having said so much about ballast, it is time we had a look at starting devices. So we saw the first and foremost thing was to have a ballast which was a inductance in AC and a resistor on DC, or an electronic version which basically converts the input DC into high frequency AC. Now in order to have the lamp glowing, because what lamps are we looking at? We are looking at the lamps based on electroluminescence and fluorescence, that is gas discharge lamps like sodium vapor lamps, mercury vapor lamps and normal fluorescent lamps or tube lights, which we use quite often. This not much of accessories are necessary for the incandescent lamp apart from control gear, which are integral part of the luminaire. Now, here the overvolting is necessary for the arc discharge to take place, and that is obtained through starting devices. So, there are two things that are two categories of starting devices, which are called starters and igniters. Starters are simple devices which all of us are familiar. The familiar cylindrical object placed in a open fluorescent lamp on a batten type is a starter. It is a simple switch, it is a bimetallic switch which upon passage of current gets heated and thereby creates the required interruption in the series RL current. As opposed to this, we have a category of starters which are called igniters. The only exception to this requirement is the high pressure mercury vapor lamp, because they operate at voltages and the pressurization of the mercury gives the required ionization. Whenever the voltage, this stays voltage greater than Vs, we need a starting device. What do we mean by that? We mean that the voltage required to initiate the discharge is greater than supply voltage, and oftentimes it is placed along with the ballast, and this could be part of the luminaire. In fact, the most street lamps which we are seeing based on sodium vapor or mercury vapor, they have the complete accessories located within the luminaire. We talked about, say, preheated filaments. That means there is a certain transformer located within the luminaire which gives the required lower voltage to keep the electrodes continuously heated. All this is possible by having the whole thing within the luminaire. The simple thing as a starter, known as a starter, is a switch start, as already told. It is a bimetallic strip which opens upon heating or reheating. When cooled, they again close and the circuit is completed. Now, as long as the lamp is glowing, this remains open. So, this is the most simplest form of starter. The only, as we said, we talked about the thing, there are certain areas where you need starterless circuit, rapid start or instant start. These are highly useful in certain explosive areas where the operation of a switch which may lead to a spark is not permitted, or such places we do use, and they are very useful for explosive environments and outdoor, because outdoor application of light, see, the moment you have a starter, you do find that there is some finite time delay. In talking of discharge lamps, we talked about the startup time, and those startup times which were very large in the initial stages, though have come down to 3 to 4 minutes these days, but it is considerable, and therefore you have a starterless circuit. It is very good for the outdoor application where you want very fast build up of the light flux. These are termed rapid start and they are continuously heated electrodes, as already told. They have a low voltage winding which is part of the ballast, and the it remember these lamps are again, apart from having the preheated filaments, they also operate on much higher voltages. That is one lacuna, and they are coated with a water repellent coating on the outside, so that there is no condensation on the envelope, which can reduce the temperature of the filaments, which may come in the way of a heated filaments remaining heated all the time. As opposed to this, we said there are other starting devices which are called as igniters. These are small 3 electrode devices. How are they? These are like our transistors or thyristors or triodes. These are basically 3 electrode devices, wherein by a control pulses given to what we call gate electrode, they go into conduction mode, or they can be disconnected, and these are often found used in the discharge lamps employed like sodium vapor lamps. Now, in fact, if you look at the voltage of operation required for the discharge to take place, you have metal halide having anywhere from 600 to 700 volts, low pressure sodium vapor lamps needing 400 to 600 volts. Remember, this is not the operating voltage. If you see carefully, the utilization is at 400 volts 3 phase, which translates to 240 or 230 volts on single phase. So, they do need a starter. We said whenever the voltage required for initiation of the discharge is more than the supply voltage, one needs a starter. The starter could be a simple switch or an igniter. In fact, it is like a thyristor which generates a set of high voltage pulses, and they are interrupted once lamp glows. Incidentally, the high pressure sodium vapor requires about 3 kilovolts as the starting or initiation voltage. So, these are give us a clear idea that we do need a starting device, we do need a device to control the current or the current limiting, which we got in the form of a ballast. So, we have the accessories wise from a control point of view, apart from luminaire. Luminaire itself is the fundamental control device which directs the light flux where it is required, and then you have ballasts which enable in getting the required over voltage, like we see that metal halide needs about 600 to 700 volts starting voltage. This is obtained by having a starter. The starter could be a simple switch or an igniter. Now, this apart, from a control point of view, we were saying we could need different light flux levels at different times. You consider a typical drawing room of a residence, and the different situations, like when you are basically doing some study, the amount of light required on the work table is more compared to when you are basically sitting and relaxing, listening to the music. Now, this is often achieved in different ways. One could be having 2 categories of lighting systems, one for the general lighting of low level, then 2 some local lighting which can give the increased light levels on the task. So, this is what we call local plus general lighting. That is, you have a general lighting for the complete movement in the room, and the other activities which do not require intense light flux, but critical tasks of writing, sewing or maybe soldering, these need more light that could have a local lighting. This apart, the general lighting itself may need to be controlled, and this is possible with the help of electronic controls. And one of the important control that may be used are known as dimmers. The dimmers per se are nothing but which control the input voltage. In fact, if we are using incandescent lamps, it is a very convenient thing. How do? We reduce the voltage, thereby the light output reduces. This voltage regulation employing dimmers is possible, and these dimmers, as already told, are just like the regulators that are employed to control the speed of the fan. This block in fact represents a dimmer would have a constant voltage as input with a variable voltage coming out. In fact, since we are using AC's electrical alternating current, the best variable device would be a kind of a auto transformer. Our transformer is basically working on a principle of a conduction transformer. Now, that is how, in fact, since the early days small auto transformers were employed essentially for light controls in getting the reduced levels or increased levels using our transformers. They were also known as dimmer stats. Now, there is another application which is possible is to have different wattages. Imagine having a light illumination system with two levels of wattages. Electronically, one could control getting the light output at different wattages depending on the requirement. And one area where you could think of two distinct light flux levels are for street lighting. The major aim of street lighting is easy movement of people on the road and the vehicular movement, and as can be seen, more the number of people using the road, larger the traffic vehicular flow, the higher would be the levels of lights required. When do we need? We need essentially from sunset to sunrise. However, remember, most roads are hardly used say beyond midnight, maybe these days close to midnight, earlier days it used to be say around 10 p.m. So, this is where it is very interesting that one control scheme could be that you have two distinct circuits, one circuit for every alternate lamp. So, during the increased traffic levels, say from sunset to midnight, all the lamps are on. This will be again reviewed when we are talking about the highway and street lighting. The other approach would be to have each lamp having, or each lamp system having two sets of lamps or wattages. In fact, these days we do get the accessories meant to be operated at different wattages. So, we can suitably program the controllers to switch on higher wattage from sunset to midnight and later on the lower wattage. This is other simple thing would be you have two lamps in parallel during sunset to midnight and possibly one lamp switched off after that. This is all possible, and they are employed in luminaires, and typically lamps when employing igniters are kept at a distance of at least 2 meters from the igniter. Now, whenever we are using igniters we have been talking about are controlled switching devices which are employed essentially in discharge lamps of that kind. Now, this shows the igniter along with the ballast and power factor correction capacitor and the metal halide lamp. Now, we said metal halide lamps are one which have a starting voltage anywhere from 600 to 700 volts. Observe one thing, the ballast out here has got a marking 240 and 220, that is in fact it also has got a provision to operate or choose the required inductance based on the input voltage. This is because there are certain areas where you may have consistently low voltage or certain areas where consistently higher voltage level, though we are expected to have certain guaranteed voltage. This is designed to take care of both circuits. As can be seen, power factor correction capacitor is placed right across the line and neutral. So, the power saving we were talking about using a multi-watt situation. In fact, this is also possible in the way of having what are called as a multi-watt ballast. When we were talking about the multi-watt application, we talked about a scheme which may be useful in lighting the roads. We said typical road lighting is necessary from sunset to sunrise with increased illumination levels during the heavy traffic, that is from sunset to say midnight, and some residual lighting necessary only from the security point of view from midnight to dawn. So, in this situation we can have, we said, two lamps located or two circuits, one circuit for the heavy traffic period, the other. As alternatively, we do have ballasts available for multi-watt consumption. In fact, here is a circuit which shows two distinct wattages, 150 watts and 250 watts, and this is termed as multi-watt ballast. This, so if we are using this, let us say we allow the lamp or wire the control circuit such that the lamp operates at 250 watts, say from evening to the midnight when the vehicular traffic is very high, and then later we allow the lamp or the control circuit switch over to 150 watts. This is possible through electronic control circuits which are based on clocks or timers these days. Now, in fact, this would have been difficult earlier days because if it had to be manually switched off, but since we have reliable electronic timers available these days, clock based switches, we can do this. Now, in fact, these are also called trendsetters, and they, as already told, they are using multi-watt ballasts, and the important thing is to select the appropriate setting. In fact, a more easier control mechanism could have been to use light operated switches. That may not be useful in selecting the wattage, but control point of view, instead of a manual switching on or switching off, you have a light operated switch which basically detects the ambient light, switches on the circuit or switches off the circuit. Like you need to switch on the lamps at say 5 in the evening, then it detecting the low ambient light, the circuit goes on. Basically it works on what are called as light dependent diodes, and they go into conduction mode. The same thing can be used because by the suitable design of windows based on the light entering, one could in fact have controls design. This of course shows how that multi-watt ballast could be used on low wattage for the entire night and high wattage for such a period when you really need in the evening. So, in essence, what we have seen, the illumination system which comprises of the lamp and the luminaire, luminaire being the physical structure which supports the lamp, which protects the lamp from the environment. Depending on the area of use, it needs to give all the protection. Like outdoor situation, it has to see that there is no moisture entry, and it has the power controls. In fact, the primary control of light flux is through luminaire itself, which may have a reflecting coating on the interior of the luminaire, or it may have reflectors based on mirrors placed behind the lamp, or it could be prismatic reflectors. That is the primary control. Then the electronic circuits which can selectively choose the lamps within a set of lamps. That is, if you have a luminaire with 4 fluorescent tubes, depending on the requirement, one may need to switch on 2 or 4 depending on the flux levels. One can have controls inbuilt. In fact, today one could control them through remote controllers, electronic controllers. Then the most common applications have been to have electroluminescence and fluorescence, which are all discharge lamps requiring that the current be limited. In order to limit the current and in order to have a good startup, we need accessories. So, in summary, control gas are the accessories that help in controlling the requisite amount of light flux on the work plane. Gas discharge lamps are constant current devices. This is achieved by use of ballasts. Requirements of good ballasts are: it should not have any power loss, should offer high impedance to audio frequency, should suppress EMI, RFI or TVI, and provide ideal starting conditions. And at the same time, power factor has to be maintained as good as possible, and this improvement is done using capacitors in series. The accepting high pressure mercury vapor lamp, all vapor lamps have the starting voltage requirement much higher, therefore, than the supply voltage. Therefore, starters and igniters are required or used as starting devices. Igniters are basically small 3 electrode devices fired by control pulses from small electronic circuits. Apart from local and general lighting, dimmers and timers are useful in controlling the flux levels as well as the energy levels. The tutorial questions are: why are inductors preferred for use as ballasts? What is the disadvantage of using inductance as a ballast? How can it be rectified? How can we stabilize current when a DC source is used? What are its disadvantages? What is the principle of operation of starterless circuits? What is its usefulness? What are switch type starters? Answers to questions of the previous lecture: which type of lighting are used for general lighting and why? Incandescent and fluorescent lamps are preferred because they have a good color rendering index and provide near daylight illuminance. What are lowers? Lowers are the openings with slanted slates, often used with luminaires to control and direct light. What are the different luminaires considered placement wise? Box type, recessed in the ceiling, mounted on a surface, suspended from a ceiling. These are the various types of luminaires one may come across. What type of lighting is used in industrial lighting? For interior lighting, fluorescent lamps with matte white reflectors can be used, whereas for high bay discharge lamps with mirror reflectors, essentially employing sodium vapor lamps, is used. What are the different types of emergency lighting used? Emergency lighting is escape lighting, which is just sufficient lighting. The safety lighting, about 5% of the normal lighting. Then standby lighting for activation of vital implements when power fails. Thank you.